Should I start? Okay, good morning everyone. Okay, what they write there, that will be visible there, na? Good morning everyone. Enable the live chat. Good morning everyone, good morning. Are you there? They are not able to write? It is not visible, no one's. See, sound is coming? It is on, na? Now someone are writing. Good morning everyone, good morning. Now now your presence is being registered. All good morning, good morning, good morning. Okay, so how are you? How is the Ganesh Chaturthi going on? You are celebrating Ganesh Chaturthi? Okay. Hello, very fine. So let us start. Oh, very fine, very fine. All these days I was missing you very much. And luckily I am here to start friction. Okay, so let us start now. Okay, so see, friction is just an extension. It is just one force. It is just one force. Okay, see, in Newton's law of motion, you must have come across many types of forces. You have read tension, you have read normal reaction, you have read tension, you have read normal reaction, maybe you have read spring force. These were all different kinds of forces. Okay, just another type of force is friction. So friction is of two nature. We are going to start. See, first of all, origin, friction is of electromagnetic origin. Friction is of electromagnetic origin. See, you all know normal reaction. Okay, normal reaction is of electromagnetic origin, because if you sit on any object, suppose you are sitting on the bench or the table, wherever you are sitting, when you sit, you actually compress their molecules. This is the molecular level diagram of the bench. You are sitting on bench means you are sitting on these molecules. Okay, the moment you sit there, molecules got displaced slightly lower, and then surrounding the neighboring molecules push them back, and that is a mechanism of creation of normal reaction. This is called electromagnetic origin, because origin is from interatomic forces. Intermolecular forces are of always electromagnetic origin. So friction is also like that only. It will depend on normal reaction. Since normal reaction is of electromagnetic origin, friction will also be of electromagnetic origin. They can ask you in theoretical question one-liners. Never ask, but if they ask, just remember it is of electromagnetic origin. Now see, first of all, solid friction we are depending on. Just now we completed viscosity in liquids. Okay, their friction was eta A delta V upon delta Y. This was wet friction, viscosity, or friction between liquid layers. Their friction was depending on area of contact. You must be remembering, friction was depending on area of contact. But this is not in the case of solids. Experimentally, it has been observed that in case of solids, there is not much dependency on area of contact. So friction is independent. Friction is independent of area of contact. These are the famous lines that that are just introductory for friction. Okay, so concentrate. This is track one, na? Concentrate. Friction is of electromagnetic origin and is independent of area of contact. Now see, friction is of two types. Everyone just brace yourself. Friction is of two types. Namely, one is static friction. Static friction, second is kinetic friction. Second is kinetic friction. Any problems that we come across, we have to decide that which friction is in the play, whether it is static or whether it is kinetic. Depending on that, answer will depend. Okay, so I will tell you how to decide that static friction is acting or kinetic friction is acting. So in the next page, see, static friction acts when okay. I am giving you all the cases where static friction is in play. So first of all, I will write this friction will act when there is no relative motion between contact surfaces, but there is tendency for it. Just copy this, I will explain. Static friction opposes tendency of relative motion. Opposes tendency of relative motion. Just copy this, I will explain this. Suppose, now I will explain. Suppose wherever you are sitting on a bench like this and listening to the class, sitting on bench and listening to the class. On you, no external force is acting. See, suppose this is contact surface and a block is kept, or you may be sitting here on this surface. If I ask you, what is the force on this block, or on the bench, suppose the book is placed, what friction force is acting on this book? I will say there is no tendency for this block to move. Tendency is defined as, first of all, whenever you have to define is there tendency of motion or not, what you do, without friction, don't apply friction, and without friction just check, without friction, is there any net force in the direction of motion? If there is net force in the direction of motion without friction, then I will tell that tendency is there. To oppose that tendency, friction will arise. See, I am telling you what. Here, if I ask you, in this diagram, is there any external force? No. You have to see, this is the surface, direction of motion is parallel to the surface. You have to just decide that parallel to surface, is there any resultant force excluding friction? In this case, nothing is there, no tendency, F net equal to 0. I will write no tendency. Since there is no tendency, friction is 0. Friction is 0. In the next diagram, see, I will tell you. Suppose you are, it happens now. Suppose wherever you are sitting, you slightly pull the bench in front of you, slightly, not like that, just slightly by two fingers, you push the bench. Bench will not be moved. But since you are applying some force, due to that, tendency has arrived. If this surface is smooth, even a small force can accelerate this. Okay, so see, direction of motion is parallel to the surface, and since a force is there that I am giving it, so due to this force, a tendency has arisen. Okay, and to oppose this tendency of motion, what will come into picture? Static friction will come into picture. Static friction will come into picture. I will explain more, but right now understand how do I define tendency? Except friction, check if there is net force along direction of motion. if there is net force along direction of motion, then there is tendency. To define tendency, what you do? Do not draw friction just to start. Do not draw friction, because I have to guess friction is of which nature. Just do what? Except friction, draw the FBD. Okay, in the FBD, just figure out in the right direction of motion, is there any net force? If there is net force, I will say that object is trying to move. To oppose that tendency to move, static friction come into play. Now you will get more feeling of that. See. Static friction is self-adjusting force. These you have to write. Static friction is self-adjusting force which acts according to requirement to oppose driving force within its limit. I will explain. Just right. What I tell you must have seen in Newton's law of motion. Normal reaction is a self-adjusting force that depends on the requirement. Just like that, static friction is also a self-adjusting force. Self-adjusting means it is not a unique value force. Like you have mass m. What is your weight? Mg. Mg is unique force. Your weight is not self-adjusting. It is a different method. At which time our weight increases, so our mass increases, so our weight also increases. But static friction does not have any unique value. Its value depends on the requirement. It is so intelligent force. Okay, it just senses the requirement, and according to requirement it assumes its value. But there is a limit. Limit is called maximum value of static friction. Static friction's maximum value is also called limiting static friction. That is defined as mu s into normal reaction. You better know. Mu s is called coefficient of static friction. This is called coefficient of static friction. This is the maximum value. Okay, if required value is less than the maximum value, maximum value, static friction will assume that value. Suppose I am giving you that, suppose static friction's maximum value is 10. And requirement is for 2 only. So it will assume value of 2. Requirement is for 4 only. It will assume value of 4. Requirement is of 8 only. It will assume value of 8. I think you have copied. In questions, mu s will be given. Just multiply with normal reaction and you will get an idea of the maximum value static friction can attain. Static friction can attain. Now see, I'm just giving you data. Suppose I have a block of mass 2 kg. Okay, and here mu s is 0.2. You can see from the previous diagram, mu s is a dimensionless number, because see, LHS is force, RHS normal reaction is already a force. So I can write mu s equal to friction upon normal. Numerator is force, Newton. Denominator is force, Newton. Cancels. Coefficient of friction is a dimensionless number. They can ask you in the exam. Coefficient of friction is a dimensionless number. Now see, I am giving you a case that mass is 2 kg, coefficient of static friction is 0.2. I am asking you, find limiting static. Limiting static friction. How will you solve? What I told limiting static in my mind. L I am writing L for limiting static. Okay, in my mind what is going on, that limiting static friction I know, I can sing that, I know mu s into n. See, mu s I gave you 0.2. Normal reaction can be obtained just by drawing a simple FBD. Normal reaction is 20. Normal reaction is 20. I can write there is always an equilibrium perpendicular to the contact surface. Okay, contact surface is ground. Normal reaction is 20. So see, answer is 4. Answer is 4. Means this is the maximum static friction, not the unique value of static friction. Okay, now I can ask you that suppose on this mass, suppose on this same mass mu s is 0.2, I am applying a 2 Newton force. I am applying a 2 Newton force. What will happen if, check if the object moves or not. Check if the object moves or not. If it moves, what is the friction? What is the friction? Tell me, if check if the object moves or not. Check if object moves. What will be your answer? Yes or no? Yes or no? Tell me, tell me. Tell me. No, it will not move. Very nicely answered. See, what I can tell, how I can tell, see. Now see, is there any tendency of motion? Definitely. Now I'm starting from the basic, just concentrate. What I told you, to Gauss tendency, do not draw, assume the surface is smooth. Assume for one moment. And draw FBD parallel to the direction of motion. Direction of motion is x-axis. So in the direction of motion, only one force is there, 2. Unbalanced force it is, so there is tendency of motion. To stop the tendency, what is the requirement from mechanics? What is the requirement, required value? What is the required value to stop the motion? 2 Newton. Now see, physics or mechanics require 2 Newton value of friction. Physics demands friction should assume 2 Newton. Now check, can friction assume 2 Newton? Definitely it can assume 2 Newton because maximum value is 4. So maximum value is 4 means below 4 it can achieve any value. If requirement is 1, it can assume 1 value. If requirement is 2, it can achieve 2. If requirement is 3, it can achieve 3. If requirement is 4, it can achieve 4. But if requirement is 5, it can never achieve 5. Like that I have to guess. So here required value is 2 Newton. That is equal to limiting static. That is equal to limiting static. So I will tell that friction's value is 2 Newton. 2 Newton. In exam, what error do we make? If they ask me friction, we just go and write mu into n. That is a mistake for static friction. Static friction's maximum value is mu into n. It is not the only value of. It is not the only value. The actual value of static friction depends on the requirement. And what requirement? Requirement, it will take value according to the requirement that how much value is needed to completely cancel the driving force. Here driving force was 2. So force of 2 Newton was required in opposite direction to balance that. So requirement was 2 and 2 was well within the limit. So it is assumed to achieve that value. I think you have guessed. You have understood. So I will give you 2 or 3 diagrams. You have to tell me if the object moves or not. So what we concluded, to be able to move, the force that is driving should be greater or equal to maximum static friction. It is like a simple situation that suppose I am pulling this block with 10 Newton force. You want to drive it towards right. So natural case will arise that how much force you need to apply to move this force. You will tell that till the moment you will tell that if you apply 1 Newton, you will not be able to drive. You apply 9 Newton, you will not be able to drive. But you apply 11 Newton, you will be able to drive. If you apply 12 Newton, you will be able to drive. Any force you can apply that is greater than the opposing force. Okay, and in this chapter, what is the opposing force? Friction. Okay, so that is the conclusion, that if you want to drive any object, if you want to cause motion into an object, your driving force must be equal to maximum opposing force. Maximum opposing force. And what is maximum opposing force? Limiting friction in this case. So I have wrote, to be able to move to be able to move an object, driving force must be greater than or equal to the maximum static friction. Equality is the condition of just moving. When driving force is equal to static friction, object is not moving, object is on the verge of moving. Okay, so that so from the language of question, you have to guess that what you have to answer. See, suppose I am asking you in all the diagrams, minimum minimum you have to tell so that object moves. If mass is suppose 10 kg, mu s is 0.3, you have to tell me what is the minimum force needed to you have to tell F minimum to move the block. Keep solving in all the cases. Two similar questions I have given you. Greater than 30 Newton, greater than 30 Newton. Oh, you are answering so quickly. Very nice. See, I will just start checking that in the direction of motion, there is a single force, means there is a net force. Okay, so due to this force, tendency of motion is there. So friction will try to oppose this, definitely. So friction is opposite. And what I told you, to be able to drive, my force should be greater than or equal to the maximum value of opposing force. So what is the maximum value of opposing force? Just go and check. Limiting friction is mu into n. How much is n? Weight is 10g. So normal reaction is also 10g, means 100. 30 Newton is the maximum value of opposing force. Okay, so I should apply a minimum value of 30. See, at 30 object will not move. Okay, but even if I slightly exceed 30.01, I apply, object will move. 30.0001 I apply, object will move. 30.0000, you write 0 for 3 years and then write 1, then object will also move. Just greater it should be. So that just greater is not defined actually. Okay, I can write as many zeros as possible and then I write 1. Okay, so in exam, if they ask you minimum force, just tell that you have to apply equal to static friction, because how much just greater, it is not mathematically defined. Just tell that at least you should be able to apply equal to limiting static friction. You slightly exceed that value, an object will move. Like that I have to tell. Okay, now see, in exams, they will give you this question. Instead of applying a force directly, what they are doing to create a force, they are connecting a string and suspending a mass m here. So there I applied how much force I need. Here I will apply how much minimum mass I should hang so that this 10 kg moves. You will apply directly. Okay. Minimum mass to move 10 kg block means motion has just started. So see, there my force F was driving. Here who is responsible for driving? This weight mg. Due to this weight, m mass has tendency to go down, and due to that tendency, 10 kg has a tendency to move towards right. So this weight will create a tension that is equal to mg. This is just moving, so there is no acceleration. So I can write T equal to mg. And this T equal to mg is causing a tendency of motion for 10 kg object. So what I can tell, again the same cases, mg is 100, normal reaction is n up, friction. My driving force mg should be at least equal to or greater than the limiting friction. So what I can tell, mg is greater than equal to mu s into n. So see, G is 10. So 10 m greater than equal to 30. So m greater than equal to 3 kg. So minimum mass is 3 kg. Minimum mass is 3 kg. You could have solved by just using the equality also. I have just written inequality. You can solve by writing equality. No problem. Greater than means if you are able to drive by using 3 kg, you can definitely be able to drive by 4 kg, you can definitely be able to drive by 5 kg. So many answers are possible, but minimum is 3 kg. Minimum mass is 3 kg. I think you all are getting. I think you all are getting or not, getting or not. Oh, so sweet people, very intelligent, just able to understand very fast. Now the surprise question comes. 20 kg block. So I think you have got the previous one. I'm adding one more question there only. Then you will write the next one. See, in previous question, what I did, I put a mass on the horizontal table and I suspended a hanging mass there. And I was interested in calculating the minimum mass that is required to move the object placed on the table. Similar question I can ask you that on a table, this is a table having suppose mu equal to 0.25. On this table, what I am having, a chain is there that is hanging. Okay, so I can ask you that suppose total length is L. What is the minimum length that I need to hang so that the chain starts slipping? Okay, find fraction of minimum fraction of length that should be hung to slide the chain. This is the question. I think this question you can draw similarity from the previous one. Okay, what I told, hanging portion is responsible for creating tendency to move. Okay, so you will yourself feel from your daily knowledge that suppose very small length is hanging like this, chain will not slide. Suppose you hang somewhat more, chain is still not sliding. But if you keep hanging mass increasing, then a moment will definitely come when it is just starting to move. After that, if you hang more, it will fall fast. Okay, so this is the question. You have to sense the condition for the condition that when the chain is just able to move. What I will tell, how I should think, tell me the same thing, that they are asking me condition so that motion is just started. I will again tell that driving force should be equal to the maximum opposing force. Now since who is driving, see, chain is hanging. Suppose this is the x length that is hanging. I am assuming total length to be L. So total length above the table is L minus X. What they're asking, first of all, tell minimum fraction of length that should be hanging. Fraction of length of hanging length is X, total length is L. So fraction of length hanging is X upon L. They are asking you X upon L. Fraction of length that is hanging. Fraction means your length upon total length. Okay, so that is what they are asking you. So see, tendency of motion is created by the hanging weight. Hanging weight is what? This much. Just like the previous question, there I showed you directly a hanging mass m, so you wrote that mass. Here hanging mass is the entire length, this one, so I have to calculate this mass. So what I can tell, make it a routine now. Whenever there is a chain, rope, this kind of problem, what I can write, L length has mass m. Each 1 meter will have mass m by L. So I need mass of X length. So mass will be m by L into X. Simple unitary method. 1 meter has mass m by L. So X meter will have mass m by L into X. I also need mass of L minus X length that is lying on the table. So L minus X length will have how much mass? 1 has m by L. So L minus X have m by L into L minus X. In the exam like condition, do this calculation very fast. Remember, 1 meter has mass 2 kg, so 2 meter will have 2 into 2, 3 meter will have 3 into 2. Here 1 meter has m by L, so X meter will have m by L into X, simple unitary 1. So I can tell that this hanging portion has weight how much? Mass is m by L into X and into G. This is responsible for creating tendency to move. This must be equal to the maximum opposing force. Friction is not acting on the entire length. Friction is only acting on the portion that is lying in contact with the table. And that portion is L minus X. So friction force will be how much? I have to write maximum friction, limiting static. That is equal to mu s into n. And see, length, mass of hanging portion is, you have written m by L into L minus X. This is mass into G is weight, and normal reaction is equal to that. Okay, so static friction, so maximum value is mu s into n. So I can write mu s is mu s, suppose, into n is how much? M by L into L minus X into G. Okay, now I have both the quantity. This is the driving force, m by L x G. This is the maximum value of opposing force, and what we have developed, the driving force must be equal to the maximum value of opposing force for the motion to just start. So I can define, I can now write a defining step that for motion to move, driving force must be at least equal to the maximum value of opposing force. So my driving force is m by L x G, and that is equal to mu into m by L into L minus x G. See, m by L gets cancelled, G gets cancelled, and you are very near to the answer. Just that you need to believe that you are close to the answer. Segregate x. See, this mu x will go into LHS. So I get x plus mu x equal to mu into L, and x becomes mu upon 1 plus mu. Just put the value of mu and you will get the answer. So this you can remember. First of all, you copy. I moved very far away. First of all, you copy. Just a single concept we are using time and again, that if I want that some object moves, okay, then I should ensure that First of all, I should have a driving force. That driving force must be able to um, completely balance the maximum opposing force. And here in this case, maximum opposing force is the limiting static friction. And so I think you have copied, and you can remember that x by L, maximum fraction of minimum fraction that can hang is mu upon 1 plus mu. If x is less than this, object will not move. If x is greater than this, object will definitely move. This is the condition. I think you have copied. In exam, they may give you the value of mu. So if I remember mu upon 1 plus mu is the answer, just put mu and solve. Even if you do not remember, question is solvable within 3 lines. No problem with that. But if you remember, you can save that extra 5 seconds. So I think I should move. So we just remembered x should be equal to mu upon mu plus 1 into L. Here object is on the verge of just moving. If x is less than mu upon mu plus 1 into L, chain will not move. Chain will not move. If x is greater than mu upon mu plus 1, chain definitely moves. Chain definitely moves. So frame this slide into your mind. Frame this slide into your mind with the concept that if I want anything to move, I should ensure that the driving force must be equal to the maximum opposing force. If you slightly increase driving force, object will move. Now it's turn of applying something more. You have now understood much things. Just apply yourself. Suppose I am having a 10 kg mass. Mu is equal to 0.2, suppose, and I am applying a force equal to 10 T. What does this mean? I am pulling this object and with time I am what? With time I am increasing my pulling force. An equation I have given you. Okay, you can do yourself. On the bench you can apply a slightly increasing force with time. Initially force is less, you will not be able to drive the bench, and if you increase, you will be able to drive the bench. See, I can ask you, find T at which block is on verge of sliding. Block is on verge of sliding. I have written a nice English. On verge of sliding means object is just able to move. Okay, that is what I have to tell. So I will apply the same thing concept again. The same concept, one concept, much used. That is the actual case. So see what you have just seen. For able to drive, my driving force must be equal to the maximum value of opposing force. So in corner, just after seeing this question, start with writing the maximum force means limiting static. Maximum opposing force means limiting static. What I can tell? Mu into n. I can orally write mu is 0.2, n is mg means 100. This is equal to 20 Newton. Till the moment my force is less than this 20 Newton, I will not be able to move. So I will be able to move when driving force is equal to the maximum opposing force, means t equal to 2 seconds. Means t equal to 2 seconds. At t equal to 2 seconds, even it will not move. Just after 2 seconds, it will be moved. That is what is the meaning of on the verge of sliding. I think you all are comfortable. You are all understanding, intelligent people. Yes, Murli, Bhavya, Vinaya, everyone's answer is correct. At 2 seconds, object will start move. So natural question arises, what is happening at t equal to 1? What is happening at t equal to 1? Tell me, tell me. B part I am writing. What is friction at t equal to 1 second? What is the value of friction at t equal to 1 second? At t equal to 1, is the object moving? Just tell me, is the object moving? You all can say, sir, no, no, sir, no, sir, it is not moving. Why? Why? Because the step I know. Step you all know. What you all know the step? Because maximum value of static friction is mu into n. Suppose this is the fresh question they have asked you in exam, so you will have to start from the basic now. So what is the basic? Just start from the limiting static, and limiting static is mu into n. I will write that limiting static is 20, and at t equal to 1, what is my driving force? What is my driving force? What is my driving force at t equal to 1? F equal to 10t, t equal to 1 means 10 into 1 means 10 Newton. Nowhere in this world 10 Newton is greater than 20 Newton. My driving force is less than the maximum opposing force, so it will not move. So now the question is, what is the value of friction? Is it 20? No, I told in the beginning only, static friction senses the requirement. It will sense that at this time, driving force is 10. So to counter this force, to balance this 10 force, friction's required value is only 10, and friction will see that can I achieve this required value. Definitely it can achieve, because the required value is less than the maximum value. Okay, so friction's value is equal to required value, and that is the answer. These types of questions are asked in the exam, and in a hurry people do just mu into n equal to 20 is my answer. That should not be the case with you all. You are being intelligent person, just feel and remember the sentence what I told. Friction is an intelligent force, it is self-adjusting, it just senses the requirement like you all. Okay, you all senses the requirement now that I have to study or not. If exam is near, you will study more. If exam is farther, you will study less, like that. So friction is as intelligent as you. It just senses the requirement, what value I should achieve to stop the motion. To stop the motion, it needs just 10, so it will assume just 10, like that. Okay, now it's time to introduce kinetic friction. Much has been talked about static friction. It's time to introduce kinetic friction. So see now, kinetic friction problems. Kinetic friction is a single valued force. It is a single valued force. It is a single valued force having value Fk, K for kinetic. This is equal to mu K into N. This is equal to mu K into N. Practically, it has been observed that mu S is greater than mu K. Kinetic friction is a very user-friendly friction. It does not give pain. Static friction was intelligent force. It was self-adjusting. So while calculating, we were in pain because we have to guess the requirement. Okay, it does not have any unique value. Kinetic friction has a unique value, so no need to apply mind at all. No need to apply mind at all. The kinetic friction has value only mu K into N. You just see the value of mu K, multiply with N, and you will get the answer for kinetic friction. Okay. So it's time to adapt to the again same previous problem. Okay, so same problem. Suppose I am giving you same 10 kg force. Mu s was 0.2. Now I am introducing mu k equal to 0.15, suppose, and my applied force was 10 Newton. My applied force was 10 T. My applied force was 10 T Newton. I am asking you what is happening at T equal to 3. Find friction and acceleration at t equal to 4 seconds. Make it easier. Instead of 0.5, just take 0.1 for mu k. Calculation will be slightly easy. Now I am asking you what is happening at t equal to 4 seconds. How can I decide? How can I decide? First of all, see, suppose this is the fresh question in the exam. At this moment, I do not know whether it will move, whether it will start moving or not. So how to start afresh? How to start afresh? Just calculate limiting static. This is the basic. I do not know at this moment that it will not move, it will start moving or not. Okay, so limiting static I will check. For that I will take what? Mu s into n. For that I will check what? Mu s into n. 2 mu can confuse you, so be purposeful, stay purposeful that I am calculating limiting static friction. Mu s I have to use. So mu s is 0.2, normal reaction is 100, so static limiting is 20. Okay, so now tell, at t equal to 4, this force becomes 10 into 4 means 40 Newton. Now see, if friction is trying to stop this 40, required value is 40. Okay, to balance 40 I need 40, but can friction assume 40 value? No, because its maximum value is just 20, so it can never achieve 40. Okay, so the object will definitely start moving. It is out of capacity for static friction. It is unable to stop that. So now question falls under domain of kinetic friction. The moment starts moving, friction switches from static friction to kinetic friction, and so mu k comes into play. So I will tell in mind in the exam that limiting friction is less than driving force. So object moves or slides, and since it slides, friction is now kinetic. So the problem has been clarified that I have to deal with kinetic friction. So now I will tell that on the block, driving force is 40 Newton, 10 t and t equal to 4. And static friction is mu k into n. And what is mu k? 0.1 into n is 100. Mu k into n is 10. I have used mu k into n. Since I classified, this step you have to do every time in solving question. Just classify what friction is there. First of all, just write limiting friction and check whether it is able to stop the driving force or not. If it is able to stop, the object will be stopped and no kinetic friction will come. But if it is unable to stop, kinetic friction comes into play and I have to use mu k into n. So now see, acceleration I can tell. Driving force minus opposing force. Driving is 40, opposing is 10. Upon mass driven is again 10. So my answer is 3 meter per second square. At this moment, acceleration is 3 meter per second square. And if they ask you friction at this moment, answer is 10 Newton. They can ask you anything. Very nicely answered. Very nicely answered. Not decided, Savira. So this is how I have to stay purposeful in the questions. Okay, what I told you, the moment you see a new question, just start with limiting friction. If limiting friction is greater than the driving force, object will not move, so friction is static. If it is less than the driving force, as was the case in this question, driving was 40, limiting was 20, so 20 was unable to stop 40. So object moves, friction shifts to kinetic, so force is mu k into n, and I draw. So we have concluded static friction is a self-adjusting force having infinitely many possible values, but that should be less than the limiting value, means mu s into n. Kinetic friction is a single valued force that is equal to mu k into n, and one important conclusion, mu s is always less than equal to mu s is always greater than equal to mu k. If in a question only one mu has been provided, okay, then by default you have to take mu s equal to mu k. If only one mu is provided, then both mu s and mu k you have to take that value. So see, now natural question arises, the childhood problem. You all must have seen. You all take a ball, roll it on the floor. After moving some distance, it stops. That is called stopping distance. And they can ask you, it stops due to what? Every one of us know it stops due to friction only. Okay, so they can ask you, after rolling how much distance object can stop. Okay, so rolling friction, we will deal in rotation motion. Okay, right now we will deal with kinetic friction only. So see, suppose a block is there and I have given it a speed u on a surface having mu s and mu k. Its mass is m. Its mass is m. I have to tell find distance it travels before stopping. They can also ask you time it takes to stop. A very plain question, a very plain question. Yes, Priya, yes, Priya, hi, hi, hi. Hi, Priya, hi. Okay, see, question by its language seems from kinematics. Okay, so how can I start? How can I start? Just start in as plain, as simplistic way as possible. So I will start with drawing a FBD. No driving force. I just give it a velocity and then the ball is out of my hand. So there is no driving force. It is sliding on the ground. Definitely sliding means no question of static friction. No question of static friction means mu s goes out of picture, out of use for me. So uh, I will write the force is only kinetic. Friction force is only kinetic. So I will write downward is mg, upward is n. So I can say kinetic friction is equal to mu k into n. Mu k into n, and I can write mu k into mg. I need retardation. So definitely this block is moving right direction. Acceleration is towards left direction. I can say magnitude of acceleration is equal to force, that is mu k mg upon mass. Mm cancels. Answer is mu k into g. Okay, so you can remember this thing. That kinetic friction causes how much acceleration? Mu into g. How much acceleration? Mu into g, and since it is kinetic, mu is mu k. So no need to write these steps in the exam like situations after now you are solving after this. Okay, just directly write acceleration produced due to friction is mu into g. Okay, now the question falls completely under kinematics. What I can write? Question is now, see, question is like block was having, now how to start in the exam? See, in the exam, how to start? I will suppose that I will know mu into g has to be used. So just on reading this question, how will I start? I will plot u like this. I will plot a is equal to mu into g, and they have asked me at what distance it has stopped. S has been stopped, asked, and T has been asked. It is for S I will be using third equation because I know V, I know U, only third equation I can use V square equal to U square plus 2S. So I am using V square equals U square plus 2S. Not needed to write this equation in the exam. Just V square you say in the mind and write 0. U square plus 2. A is retardation, so I am using minus sign. It is minus mu into G into S. Stopping distance comes out to be U square upon 2 mu G. Stopping distance comes out to be U square upon 2 mu G. You can remember stopping distance formula is U square upon 2A from kinematics also. Formula is U square upon 2A, and here A is equal to mu G. Here A is equal to mu G. You can remember like that. You must be remembering the maximum height formula U square upon 2G in motion under gravity. You thrown with speed U, retardation was G. After how much distance it stopped? Answer was U square upon 2G. The same U square upon 2A is in play there. There A was G. Here A is mu G. So keep using a simple formula U square upon 2A. No need to write these equations. Stopping distance asked means U square upon 2A has to be used. Just tell A and put that. Now it's question of time. So first equation has to be used. You all must have figured by now. So for time, what I will use? V equal to U plus AT. For making you understand, I am writing this. But if I have to do in exam, I will say V, write 0. I will say U, write U. I will say A, write mu G into T. T becomes simply U by mu into G. They can ask you symbolically or they can give you data. So anytime you can use this. Very nicely answered, Sandhya. Copy, 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 copy. I think I can move. Trimula has asked something but not visible, sir. Why there? After that, it is not visible. Right again, Trimula. So whatever you have understood, apply to this problem. I have given you that Trimula, that was retardation. For retardation, acceleration has to be taken negative. Okay, so magnitude is mu k into g, but since it is retarding, acceleration will have to be put in with a minus sign. Retardation is with minus sign, acceleration is with plus sign. See, now I have shown you a diagram in which the moment I saw this system, it was moving with speed 2 meter per second. No problem with that. So it is already moving, so no question of static friction. Okay. So in the question, you will have to be that pinpointed. Already moving means kinetic friction. They are asking you what is the acceleration or retardation, whichever is applicable, you have to tell. Definitely retardation is there, or acceleration can be there. You just tell me. So we have to find acceleration and you will have to find tension. How I can solve? See, how I will solve, you all know that in this case, see, driving force is the weight of hanging portion 30. Just I have picked driving force. Opposing force is kinetic friction here. Kinetic friction is what? Mu k into n. So n is 20, mu is 0.2.